Your elevator cable just snapped, the lights flicker, the cabin jerks, and suddenly your stomach drops. Literally, the elevator is falling. 20 stories above the ground, no help is coming, no emergency button can save you now. You have seconds to decide. Do you jump? Do you grab the handrail? Do you bend your knees? Or do you lie flat? Every move has an answer. Most of them are wrong. And in the next few minutes, we are going to test every option using real physics. Because in a falling elevator, the fall isn't what kills you. The stop is. This is a applied future where science isn't just knowledge, it's survival. Imagine you're heading home after work, your phone battery is almost dead. You're thinking about dinner, nothing unusual. Then you hear a metallic crack. The elevator drops just a little at first, then faster. The floor indicator races downward. Your heart starts pounding. Adrenaline floods your body. And in that moment, something fascinating happens. Your brain stops being rational. It starts searching for survival shortcuts. Maybe you've seen an action movie where the hero jumps right before the impact. Maybe you heard someone say to grab the handrail. Maybe you heard a survival tip online. But which one actually works? Let's freeze time and test them one by one. Here is the first thing most people get wrong. The fall itself is not the biggest problem. During the fall, you and the elevator are accelerating together. Relative to the cabin, you almost feel weightless. It's similar to astronauts orbiting Earth. They are not floating because there is no gravity. They are floating because they are constantly falling. The same thing happens inside a falling elevator. The real danger arrives when the elevator suddenly stops. Because your body doesn't want to stop, but your bones stop, and your organs don't. Your brain keeps moving, your lungs keep moving, everything inside you keeps trying to continue its journey. And that's where physics takes over. One equation explains everything. Impulse equals change in momentum. The shorter the stopping time, the larger the force. A tiny fraction of a second can determine whether you walk away or never walk again. Movies love this idea. Jump right before the impact. Cancel your speed, save yourself. Sounds brilliant. Until you look at the numbers. Let's say the elevator is falling at 50 kilometers per hour and you jump upward at the exact last moment. How much speed did you remove? Maybe 3, maybe 5 kilometers per hour. But the elevator was falling at 50 kilometers per hour. You're still moving downward at roughly 45. Physics barely notices the difference. Now watch what happens. The elevator hits. Your feet hit first. Your ankles absorb the force. Then your knees. Then your hips. Then your spine. The impact races upward through your body like a shock wave. Your jump didn't save you. It simply reduced a disaster by a tiny amount. The problem isn't timing. The problem is scale. Humans can't generate enough upward velocity to meaningfully counter a high-speed fall. Hollywood loves this solution, but physics does not. The verdict, it's a myth. Option 2, holding the handrail. This one feels smarter. If you are about to crash, hold on to something. Brace yourself. Stay secure. That's what your instincts tell you. But your instincts are about to get you hurt. Imagine the elevator stops instantly. The handrail stops too. But your body still wants to move downward. Now all the momentum is transferred to your hands, wrists, elbows, and shoulders. Human shoulders are incredibly flexible. That's great for throwing a ball. It's terrible for stopping a falling body. In slow motion, the results are brutal. Ligaments stretch, joints dislocate, bones fracture, and even if the rail doesn't break, your body might. Instead of spreading the impact across your body, you concentrated it into a few vulnerable joints. The rail feels safe because it gives you something to hold, but safety and comfort are not the same thing. Verdict, bad idea. Option 3, bend your knees. Now we are getting somewhere. This advice actually contains a grain of truth. Your knees can act like shock absorbers, just like suspension systems on a car. When you bend your knees, you increase the time it takes for your body to stop. And remember the rule? Longer stopping time means smaller force. That's good, very good, but not good enough. Because your knees only have so much travel distance, eventually they run out of room. And when they do, the remaining force continues upward. Ankles, knee, hips, spine. One after another. The injuries may be less severe than standing straight, but the risk remains enormous. Physics approves of this idea, just not as much as people think. Verdict better, but still dangerous. Option 4, lying flat. This option feels wrong. It feels passive. It feels like giving up. And that's exactly why most people ignore it. But physics loves it. When you lie flat, two important things happen. First, the force spreads across a much larger area. Instead of concentrating the impact through your ankles and spine, it distributes it across your body. Second, your body gains slightly more stopping time. Not much, but enough to matter. And in high energy impacts, tiny improvements matter. Imagine two people, one standing, one lying flat. Both experience the same crash. The standing person's skeleton becomes a direct pathway for the force. The person lying flat distributes more of that energy. And if physics had to choose one option, this would be it. Verdict, best chance of survival. So, what did we learn? Jumping doesn't save you. Holding the rail can make things worse. Bending your knees helps, but only a little. And lying flat gives you the best chance physics can offer. But the biggest lesson isn't about elevators, it's about understanding the world around you. Because when things go wrong, panic asks questions, physics provides answers. This is applied future where science isn't just knowledge, it's survival. I'll see you in the next one.